Imagine a world where you can describe an image, a melody, or a complex scientific concept, and an AI can bring it to life with stunning accuracy and creativity. Generative AI is an application of deep learning where machines can produce original art, design innovative products, and even compose music. This is not just about automation, it's about augmentation. Generative AI represents a fundamental shift in how we interact with machines. In this video, we'll discuss generative AI concepts like large language models, prompt engineering, retrieval augmented generation, and fine-tuning. We'll also touch on diffusion models and how they work. Now, are you ready to dive in? Unlike traditional AI systems designed for tasks like classification and prediction, generative AI focuses on creation. These AI models are trained on vast amounts of data, learning the underlying patterns and structures, enabling them to generate new content that reflects the style and characteristics of the data they were trained on. There are many types of generative AI models. The two most popular ones today are generative adversarial networks and variational autoencoders. Generative adversarial networks, or GANs, consists of two neural networks, a generator and a discriminator. The generator creates new data, whereas the discriminator evaluates its authenticity. Over time, this adversarial process sharpens the generator's ability to produce highly realistic outputs. Variational autoencoders, or VAEs, build on autoencoders made up of two neural networks, an encoder and a decoder. The encoder optimizes for more efficient ways to represent data, whereas the decoder looks for more efficient ways to regenerate the original dataset. This allows the generation of new content that stays true to the original data's essence. VAEs help to boost the outputs of diffusion models, which we will talk about later in this video. Let's zoom in on one of the most powerful tools currently used in language generation: large language models, or LLMs. They are the backbone of many AI applications today. But what exactly are they? How are they built? And what can they and can't they do? Large language models are built using vast amounts of text data. Think of everything from books, articles, and websites to social media posts and beyond. These models are trained through a process called supervised learning, where they learn to predict the next word in a sentence based on the words that came before. This process is repeated millions, even billions of times, across a massive data set, allowing the model to learn language patterns, context, and even some basic reasoning skills. So, what are LLMs good for? Thanks to their training, they excel in a variety of tasks. LLMs can produce coherent and contextually relevant text on almost any topic, making them great for content creation, writing assistance, language translation, and functions like chatbots and virtual assistants. In the field of software development, AI coding assistants are helping developers suggest code snippets, identify potential bugs and solutions in real time. They can even generate entire functions based on natural language descriptions, allowing developers to focus more on problem solving and less on repetitive tasks. We'll be analyzing the impacts of AI on tasks, process, and workflows in another video. As powerful as large language models are, however, LLMs aren't without their limitations. Hallucinations refer to instances where the model generates text that is plausible sounding but factually incorrect, misleading, or entirely made up. These occur because LLMs generate responses based on patterns learned from vast amounts of data, rather than verifying facts or referencing real-time information. Let's take a look at the reasons why these could occur. First, structured data analysis. LLMs struggle with tasks that require precise calculations or analysis of structured data, like predicting housing prices from a dataset. This is where traditional machine learning models built for prediction or regression analysis excel. Second, fact-checking. Since LLMs generate text based on patterns in their training data, They can sometimes produce information that sounds plausible but is incorrect or outdated. A knowledge cutoff could exist if real-time or updated knowledge is required, causing gaps in data. Next, we have task-specific knowledge. While LLMs have broad general knowledge, they may lack the depth needed for very specialized tasks unless they're fine-tuned on a specific dataset related to that task. Lastly, understanding complex contexts. They can misunderstand or oversimplify complex contexts, leading to responses that miss the nuance of a conversation or topic. In summary, large language models are incredibly versatile tools that can handle a wide range of language-based tasks. However, their limitations mean that they're best used in combination with other AI techniques, like retrieval augmentation and fine-tuning, which we'll cover in a later chapter. While generative AI models possess remarkable creative abilities, without proper direction, their outputs can be unpredictable. This is where prompt engineering comes in. Prompt engineering is the art of crafting effective prompts or instructions that guide the AI model to generate the desired output. A vague or ambiguous prompt will likely result in an output that doesn't meet the mark. The best practices for prompt engineering is to be detailed, specific, creative, and keep experimenting. Think of the AI tool as your brainstorming and thinking partner. Understanding the AI's strengths and limitations takes practice and trial and error. Additionally, online courses on prompt engineering, like the ones offered by IBM and Vanderbilt University, are excellent for further learning and practice. Remember, a well-crafted prompt not only directs the AI, but also minimizes errors and biases in the generated content. Investing time and effort into learning the foundational language and tricks of the AI tool will augment your process and allow you to capitalize on future opportunities and gains. Now that we've explored the basics of generative AI and prompt engineering, let's dive into two more advanced techniques to take your results even further: Retrieval Augmented Generation, RAG, and fine-tuning. First up, Retrieval Augmented Generation, or RAG. Think of RAG as a method that combines generative AI with a robust retrieval system. Here's how it works. Instead of solely relying on the pre-existing knowledge within the AI model, RAG allows the AI to pull in relevant information from an external database or document set during the generation process. For example, if you're using AI to generate a report on the latest trends in healthcare, RAG can help the AI access a database of recent medical studies and include those insights in the report, allowing it to incorporate up-to-date information or specific data that it didn't initially train on. Next, let's talk about fine-tuning. While generative AI models like GPT are trained on vast amounts of general data, they may not always be perfectly suited to your specific needs right out of the box. This is where fine-tuning comes in. By adjusting the model on a smaller, more targeted data set that's specific to your domain, whether it's finance, legal, or creative writing, you can significantly improve the model's performance for your particular use case. For instance, let's say you're a business owner who needs AI to generate customer service responses. Fine-tuning allows you to train the AI on past customer interactions specific to your company, resulting in more accurate and personalized responses that reflect your brand's tone and style. When combined, RAG and fine-tuning offer a powerful toolkit for enhancing your AI's capabilities. Whether you're generating detailed reports, customizing customer interactions, or creating highly specific content, these techniques ensure your AI outputs are not only accurate, but also tailored to your goals. In the realm of art and design, generative AI is empowering artists with new tools for expression, allowing for the exploration of new possibilities. One of the most fascinating aspects of generative AI, particularly in image generation, is the use of diffusion models. Diffusion models are generative models that progressively transform random noise into coherent images through a series of denoising steps. Imagine a pristine canvas slowly being corrupted with noise until the original image is completely obscured, like Gaussian noise. That's the forward diffusion process. Now, imagine training an AI to reverse this process, to learn how to remove the noise and gradually reveal the hidden image. This is called the reverse diffusion process. The reverse diffusion process is learned using neural networks that are trained to predict the noise added at each step in the forward process. That's essentially how diffusion models work. By iteratively denoising the input, the model learns to generate new images from random noise, effectively painting images pixel by pixel. This approach has revolutionized image generation, enabling the creation of highly realistic and detailed images with remarkable fidelity. Stable diffusion is a type of deep learning diffusion model designed for generating high-quality images from text descriptions. VAEs boosts the results of stable diffusion models by encoding the image into a latent space and then decoding that latent space into a new, higher-quality image. From generating photorealistic portraits to creating fantastical creatures and breathtaking landscapes, the ongoing innovation of diffusion models are exciting and revolutionary. Now that you've got an understanding of some of generative AI's core concepts, you're ready for the next step. Whether it's taking an intro to coding class, building your very first chatbot, or watching more of our videos on AI, there's tons of resources available for you to get started. I hope you enjoyed learning together in this video, and I'll see you in the next one. Don't forget to like and subscribe for more weekly content.